So I thought we'd warm up with something that all of you are really good at right now. Long division with numbers. Like 7 going into 1,235. So usually what you say is, what do I need to multiply 7 by in order to get 1? And the answer is nothing, it doesn't work. Well, how about 12 then, which are the first 2 numbers? And you're like, oh, I can multiply 7 by 1. And if I do that, then I get 7. And then I subtract. And then I get 5, and I bring down to 3. And then I say, okay, does 7 go into 53? And the answer is yes. And then the question is how many times? And you say, oh, that's 7, because 7 times 7 is 49. But there's some left over, so you subtract off. And left over is going to be 4. And then you bring down the 5. And then you say, okay, well, how do I get the 7 to go into 45? And the answer is you multiply by 6. And 7 times 6 is 42. And then you subtract and 3 is left over. And so what you can do is you can write down that you have 176 and 3/7. Or you could say that you had 176 with a remainder of 3 if you were back in elementary school. Remember those days? It works the same way. So I'm going to refer back to our practice problem, and we're going to go from there. In number 1, they say, let's divide 2x cubed minus 5x squared plus x minus 8 by x minus 3. Whatever comes after the word by goes on the outside. So you'll see that's on the outside. So later on, if you ask me, I'm just going to make fun of you, rip you new shreds. That didn't make any sense. Whatever. All right. So to do this problem, I say to myself, okay, looking at this x right here, what do I have to multiply x by to turn it into 2x cubed? Joe?
2x squared.
2x squared. So I write down 2x squared. Once I write that down, I take that thing that I wrote down and I multiply by each thing on the outside of the division. So 2x squared times x is 2x cubed. Surprise, surprise. If that doesn't happen, what are you doing? Nothing important. That's the whole point. You want to match those two things up. But don't forget about the minus 3. So 2x squared times minus 3 is minus 6x squared.
Yeah.
Now I subtract that stuff, just like we did in the previous example. So I look at all that stuff and I subtract it. Now if things work out well, the first thing always goes away. That's the whole point. So 2x cubed minus 2x cubed, there are no x cubes anymore. Negative 5x squared minus a negative 6x squared is positive 1x squared. Bring down the next thing, which was a positive x. Next step, you ask yourself, how do I make an x turn into a 1x squared? You multiply by x. So multiply by positive 1x. 1x times x is that 1x squared. Oh, don't forget about
the
negative 3.
Oh.
1x times negative 3 is
Negative
3x. I'm going to get rid of all that stuff, though, by subtracting off that line, just like we did in our numerical example. And again, if you're doing things properly, the first thing should always disappear. So 1x squared minus 1x squared, no x squareds. Positive x minus negative 3x gives me 4x. And bring down the very last thing, which was the minus 8. And the last thing I have to do is I have to ask myself, how do I turn the x into positive 4x? And the answer is multiply by positive 4. So I multiply by positive 4. 4 times x is 4x. Oh, yay, that's what's supposed to happen. Don't forget about the minus 3. 4 times minus 3 is negative 12. And then I'm going to subtract off all that stuff. So I subtract it. And the 4x minus the 4x means there are no x's left over. And then minus 8 minus a minus 12 is positive 4. And back in the day, we could have written down remainder 4. But what we're going to do is we're going to go, it's 4 over whatever the divisor was, which was x minus 3. And that's our solution. 2x squared plus 1x plus 4 plus 4 over x minus 3. Joe?
Why did you you knew that it was a remainder because x squared doesn't go into 7x as a positive number, sorry, as a number above.
Synthetic division, shortcut. Or people think it's a shortcut, it's not really a shortcut. It only works when the thing you want to divide by is a linear factor. So if you're doing linear factor division, what I mean by that is this thing right here does not have an x squared in it, or an x cubed, or x4. It's just x. Otherwise, you cannot do this. Here's how it works. Bring the 4 down. Why? Just because. It's like driving. Put it in gear and drive. Negative 2 times 4 is negative 8. Add them up. Negative 2 times negative 8 is 16. Add them up. Negative 2 times 14 is negative 28. Add them up. And negative 2 times negative 29 is 58. Add them up. Now, a miracle happens. Weird. In math, there are always clues about what to do. So, get a clue. What does the word evaluate mean?
Judge.
No. Not in math.
Analyze.
No.
Oh.
No.
Do.
No.
Hold up.
No. 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 Find the answer. That's it. That's what it means.
That's solve.
No.
Aggravates me.
This is one way to think about it, and then I'm going to show you another way.
Why is it?
Why is it what?
S.
It's a 5.
Here you go, Mason. That's for some extra help for you.
Oh, thank you.
You're welcome. And my crystal ball says I get 29. Why is that even funny? I don't even understand that. So this is one way to think about it. The reason I'm bringing it up right now, here's another way. So two ways to think about this. You can either use it by plugging in the actual value of x to find out what the answer is, or the outcome, or the output, or the dependent part of this. Or you could look for the remainder. Either way. Notice how they also gave a second clue in here, just in case you weren't watching. They used the word remainder. Two clues. When you're trying to determine whether something is a solution or not, what just happened?
She touched me.
Weird. Okay, if you want to know something's a factor, what that means is in the end, the remainder is 0 if it's a factor. So if you have a factor, the remainder is 0. So I'm going to do synthetic division and check to see if I get a 0 in the end. What goes in the little seat?
1.
How'd you know that?
That's what makes it 0.
That's what makes it 0. So 1. Very good. Thanks, Tristan. And then as I'm writing my numbers across the top, I have a 1, x to the 4th, and 0 x cubes, and 0 x squareds, and 0 x's, and -1 for my constant. It is binary code. Good job, Hannah. Bring down the 1. If you can't do this in your head, there's some issues. Sarah, I recorded this. Make sure your dad watches it. Touch her again, Catherine. 1 times 1 is 1. Add them up. 1 times 1 is 1. Add them up. Anybody having difficulty so far? Sarah. 1 times 1. Add them up. 1 times 1. Add them up.
0.
0. She said 1 again, didn't she? The answer is yes. It is a factor because we produced a 0 as a remainder. And in this rational 0 test, or rational root theorem, when you have a polynomial, which just means a bunch of x thingies separated by pluses and minuses, then if you look at the factors of the constant divided by the factors of the leading coefficient, all those possibilities are the possible rational zeros. Let me show you what I mean. Let's look at the -6. This -6 is the last thing in my polynomial. It's the constant. In the rational 0 test, they call that thing the p. Yeah. And that p has factors, meaning it has numbers that can divide into it. What goes into 6?
-3.
How about 1 goes in there?
And negatives.
How about 2 goes in there? How about 3 goes in there? And how about 6 goes in there evenly? With me so far?
And negatives.
And you could actually do the positive or the negative values of these, right? So I could have written down -1, -2, -3, and -6. Or if you want to save space, you go +or-1, +or-2, blah, blah, blah. Okay? So all these numbers can be divided into the 6, whether it's negative or positive. The other thing in the front, weirdly enough, does not have a number in front of that x cubed. So what's its coefficient? 1. So q, the only numbers that go into that first thing are +or-1. Now what I need to do is I need to take every p value and divide it by every q value. Don't do this right now. But 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. Blah, blah, blah. And then I go 1 divided by -1.